Correlation measures the relationship between two variables, and it can be positive or negative. When it's positive, it means that if one variable increases, the other one also increases. If it's negative, it means that when a variable increases, the other one decreases. And it can be strong, and it goes between from -1 and 1. And the more it is close to the extremes, more it's close to 1 or -1, it's stronger. The correlation is strong. Okay? So let's start this project here that it's going to measure the correlation between the returns of two stocks. First, we're going to import the libraries. Then we're going to input the symbols of the stocks. Let's use Apple and Google. Then we're going to choose the start date to download data. Let's use 2020. And the end date 2022. Okay. Now let's download the data. So here we have the data for those two stocks, Google and Apple. We're going to get the returns for each one of these stocks using the adjust close column data. So let's run this, the daily returns. We got some NAs here, so we're going to drop those. And now we're going to get the correlation matrix. So we can see here that when we measure the correlation, the return correlation for Google and Apple stocks, we get the value of 0.72. So it is a positive correlation, and it's quite strong as well because it's quite close to 1. Okay, so let's plot some graphics here. So here we have the matrix plotted. Okay. We also are going to plot the adjust close graphic here. So as you can see, the movements are quite similar to one another. Okay, so let's plot this one as well. So this is the return plot. As you can see, the range between the movements are quite similar. And let's scatter plot the returns as well. So as you can see here, we also have the returns values pretty close to each other. Oh, let's now measure the significance level for this correlation, which is going to show us that if it's a random correlation or not. So if we're going to use the t-test for a critical value of alpha 5%. So if we have a t value higher than the critical value, it means that our correlation is statistically significant at that alpha of 5%. Okay, so let's run this code here and check the results. First of all, let's get the correlation. How come it did not work? Let me check this. Okay. Let's run these. Let me see here. Let's get the code. get another code line here. Returns. Okay. Let's get this. How come it's not getting Apple? Let's get these. Okay, so now we have the value. And now let's run these cells over here. So we can get the t value and see if it's higher than the critical value. So as we can see here, the correlation is significant at alpha 0.5 because its t value is 29 and the critical value for 5% is 1.96. Okay, so that's it, guys. Thank you for watching.